Virtual reality is increasingly being adopted for work, with users sitting at a desk and using a physical keyboard, similar to traditional office setups, but with monitors replaced by virtual displays in VR. However, the unique capabilities of VR allow for more flexible and adaptable workspaces and postures. Our research investigates the potential of using VR for productivity tasks while lying down, motivated by the desire for more relaxed work conditions and to accommodate users with specific needs. As a first step towards this goal, we conducted user studies with 11 participants, focusing on two essential work tasks: text entry and selection of targets on a virtual 2D window. In our first experiment, we compared typing performance on a physical keyboard in supine and seated positions. For the supine condition, participants lay on a yoga mat and a pillow, with the keyboard placed on a tiltable stand. A webcam was fixed above the keyboard to provide visual feedback in VR. Our second experiment evaluated the performance of 3 different pointing techniques: touchpad, controller pad, and head-based raycasting, again in both seated and supine positions. Our results show that while text entry speed and accuracy were lower while lying down, subjective comfort levels were comparable to those in the seated position. This suggests that with further ergonomic optimization and practice, reclined VR could be a viable option for text-based tasks. For target selection, head raycasting was the most efficient method when seated, but it led to increased fatigue and discomfort when used in the lying position because of head movement constraints. The controller and touchpad offered comfortable and consistent alternatives, particularly when lying down. Our findings have implications for the design of VR interfaces for reclined use. We find that both performance and ergonomics need to be carefully balanced, as different methods may be optimal depending on the user's posture and task requirements. Our work also hints at the potential of supine VR to improve accessibility for users with disabilities or medical conditions that prevent them from working in a traditional seated position. Future work will involve more extensive, longitudinal studies with diverse users and real-world applications to further evaluate what we think is a promising new way of working.